Now we're looking at another property for algebra, and this one, the associative property. We're on page 3 of section 1.4. 1.4 is looking at the basic rules of algebra, the things that we all want to understand about algebra before we delve into solving some algebra problems, learning how it all works, and working our way to becoming experts at linear equations. That's our goal through chapter 4 of this book. So just another note on properties, and you'll hear me say this over and over again. It's worth repeating though. The reason why these properties exist, we didn't invent these properties so we could deal with algebra. These properties are based on what happens with numbers, because what works for numbers is how we then work with algebra when we don't know the numbers, okay? Because those letters represent numbers. And so when you have letters instead of numbers, the same rules should apply. It's just that we have to know how to move things around, because we can't just rely on order of operations anymore to keep making everything equal to the next, equal to a smaller amount, you know, combine all the things into a final answer. The variables are sitting in there, so how do we work with those? Well, we looked at commutative property. We can switch things around across addition or multiplication. And now we're going to look at the associative property. And the associative property has that word base in it, associate. So it's who I hang out with, who my group is. And it is a grouping property. It says that, and this is coming straight from the book, page 45, it says that if you're adding three things together, and adding is key here, you can either group the first two, and order of operations says the parentheses tell you to take care of that first two before you add the third item, or you could group the second two together and add the last two and then come back to the first. So we no longer have to just strictly rely on order of operations and go left to right. As long as everything is addition, it doesn't matter which two we pull first. In fact, we could do some sort of combination of commutative, switching around the A and B or switching around the B and C, and then take the pair that we wanted. So the idea is that you get to be able to move things around so that it benefits you, so that you can do what you need to do in terms of the mathematics and the algebra. So association also works with multiplication. If you're multiplying three things, A times B times C, you can multiply the first two, get that answer, then multiply by the third. You can multiply by the second two, get that answer, multiply back by the first. Or, and this is not distribution here. Remember, distribution is multiplication over addition. If you're having an instinct to distribute every time you see a parentheses, make sure you come talk to me about that, get some help in class, whatever it takes, because distribution is meant to be multiplication across addition, not across anything else, okay? It's this is just a way to decide which two to do first, and then you multiply by the third. Okay, and as I mentioned on the first page, these rules are stated as it only works for addition and multiplication, which makes you think you can never use it with subtraction or division. But again, it works if you make the subtraction into adding the negatives. In other words, you rewrite everything in terms of addition, then you're back to this, okay? You can also use it with division if you turn every division that you're dealing with into multiplying with the inverses or the reciprocals, okay? And this is just kind of bonus information. You're going to do just fine just to grasp onto these basic concepts. This is just planting some seeds so that it eliminates the confusion later on. Again, just focus on what the book and I originally said here. This is just bonus for now. Okay, so number 24, let's look at this. And again, let's remind ourselves what we were asked to do. Use an associative property to rewrite the algebraic expression. So it's another way of saying we're coming up with something that equals what we started with. It just now is in a different look to it. Once the grouping has changed, go ahead and simplify. Now, just a word on what simplify means. For our purposes, it will be best for you to understand that when it's said to simplify, you're going to want to distribute, to remove any parentheses, and then combine like terms. Now the combined like terms is what you're going to see most of right now, okay? Because officially we haven't even talked about the distributed property. That comes later, down at the bottom of this page actually, so we're getting really close. Okay, so when they say simplify, this is what we mean. You're looking to do these two things, and that will help make it simpler, more condensed, kind of in final form. So associative property to rewrite. So associative means that we're changing who the grouping is with, who we're going to go with first. Order of operations says I would need to add 3 plus x first. Since I don't know x, that doesn't get me anywhere. Okay, but associative property says, hey, I don't have to multiply the 3 plus x first. I can instead multiply the 9, or not multiply, I don't have to add the 3 and x first. I can regroup who I associate with and add the 9 plus 3 first, which is actually, now I can get further along. So 9 plus 3 is 12 plus x. So there's that simplification here. And 9 plus 3 is like terms because neither of them have a variable. So their variable does not exist, therefore they're exactly matching. They're constants, all right? And then you get to try number 26. 24 was addition. What do you notice about 26? It's a chance to use the associative property of multiplication. Okay, you try. All right, if you need to pause the video, do so, because here comes the answer. When you rewrite this, you end up with a regrouping of 8 times 5 and then times x. And simplified version, you would end up with 40 times x, or just read that as 40x. All right, let's talk distribution at the bottom of the page.